So thank you, Co-Rise students and anyone else for joining us today. Very happy to welcome Mihail Eric to be our guest. Mihail's background, I think I originally met Mihail at Stanford when he was working on some NLP and ML research. He went on to build ML systems in startups, and then he was at one of the foundational teams of Amazon's Alexa kind of next generation machine learning technologies, and left Amazon, did some other startups, both thinking about the ML ops and some in the ML education space. Mihail is joining us today as someone who has pretty strong opinions on some things in ML ops, and has also built some very big systems in industry, and both large and small. So Mihail, thank you for joining us. Happy to have you with us. And actually with that, so I gave kind of a quick overview, but would you like to say a bit more about sort of what you've been up to more recently? I only know the sort of highlights.
Sure. Yeah. Well, first of all, thank you, Andrew, and thank you, Judy, as well, on the Co-Rise team. It's great to be here. Yeah, I mean, I've been in kind of ML a while, and you kind of alluded to some of the past experiences, small scale startups, being lucky enough to be also at Amazon Alexa at a very interesting point in kind of the organization's evolution. And I can talk more about why that was the case, but getting involved with Alexa at kind of this pivotal period in its evolution, where we started to think a lot more about what are the next generation efforts look like to make Alexa a better platform. And so got to do that for a number of years, and then was always like really fascinated by AI education, ML education, having gone through some of the the difficulties that entails, and obviously being a newcomer and then transitioning into developing more expertise and kind of really keeping tabs on how I was learning things and trying to then really convey a lot of those lessons to other people. And yeah, I mean, since leaving Amazon about a year ago at this point, and running an AI education company that we just got acquired a few months ago, about like around 2 months ago, that we got officially acquired, and got all the paperwork signed. Have just been thinking about the next generation of things that I want to work on. So that means another startup. I mean, I'm big into startups, so have really been thinking a lot about a combination of like ML ops tooling and kind of data tooling, and then most recently just sort of generative AI. So a lot of which maybe is not a very new thing to say. I mean, everyone is kind of thinking about generative AI, but there's certainly there's a lot of interesting stuff happening in this space. And so thinking about what kind of applications, like what does this enable people to do that wasn't previously possible? I think that's really where I like to sit. The kind of questions I like to think about the most is like next generation technology and how we can empower a new subset of users or a new subset of practitioners to do something that wasn't possible before. Cool.
Yeah, I mean, just on that topic, to me, a lot of the most recent like generative models and like large language models, they turn, it's like a very big step forward in terms of technology. And that means that there's a whole bunch of like product and design ideas that you can now explore because the technology sort of enables it, that you just like wouldn't have thought about 5 years ago. So right. Yeah, I think those are pretty cool companies.
That's right.
And you mentioned sort of getting into ML. So I guess I'll advertise for your company for you. If people haven't seen Confetti, we have a bunch of sort of aspiring engineers in machine learning in the audience. So Confetti, is it Confetti AI or Confetti
That's
ML?
right. Yeah, Confetti AI, and then LLC, I guess, if you're going to be the official legal term or whatever. But yeah, Confetti AI is the name.
Yeah, so if you haven't seen that site, it's designed to like help people practice like programming exercises specifically for machine learning and data science. So it's a very cool product, and it's actually potentially useful if you're sort of preparing for different types of interviews, like coding interviews in data science. But you also mentioned your education background. So one of the standard things I always like to ask is, how did you get to be working on the things you're working on? What, I guess, starting from, were you a computer science undergraduate? Did you work on statistics formally?
Yeah. Happy to talk more about that. So I did my both undergrad and kind of grad school at Stanford. Uh, and when I joined, actually, when I started at Stanford, I was actually going to do physics originally. So I've been kind of big in math since I was basically in middle school. Like I did a lot of math competitions, and if anyone is familiar with like math counts and the AMC, maybe people that are in the States are familiar with these, like kind of middle and high school level math competitions and math Olympiads. And so I did a lot of that stuff. So I always really had a propensity for doing thinking about things mathematically and just work on math problems, and was originally going to do physics. Came in my first quarter at Stanford, took one of the kind of like the introductory level classes in CS, and just like was kind of blown away because it was just the pedagogy was so good. It was so well taught. Jerry Kane was my advisor or my teacher, and then he later became my advisor. So, getting that first taste of CS formally, where there was this very mathematical way of thinking about problems, but also very practical application where it's like an engineering discipline, right? I mean, at the end of the day, and you can build things with it. And seeing that combination was just like, this is the sweet spot where I can really build practical things, but it's very procedural and it's very like algorithmic in the way you think about things, which really is something that I find very appealing. And so knew I wanted to do CS and had kind of always been thinking about AI. Even in high school, I had read like Ray Kurzweil's The Singularity is Near, and had a lot of these kind of ideas in the back of my mind that this is something that is it's something that's worth working on. I mean, there's like a lot of interesting ideas happening here, and I think at the time that I kind of got into CS was right around the time that Andrew Ng was still at Google Brain. And they had just kind of done this whole project where they like let this neural network loose on YouTube and basically discovered cats. If people remember that, Andrew, you might remember this experiment they
The
ran.
New York Times Google cat result. Yes. If people have not seen this, man, this is 2011, 2012.
Yeah.
And it was, I guess, it was one of the very first times that like deep learning was like prominently featured in the New York Times.
That's
and
right.
The image is like this ghostly cat.
That's right.
Because if you train unsupervised deep learning systems on huge amounts of YouTube data, you end up with like a specific hidden variable that sort of seems to code for cat, without ever telling it that like cat is a thing. Yeah.
That's exactly right. Yeah. So that's the perfect context. So that was, I'm literally an undergrad and Andrew Ng is talking about this result, right? And this is the backdrop against which I was like, oh, there's something interesting going on in AI. And so again, this was right around the time of the resurgence of deep learning. Again, deep learning is not new by any stroke of the imagination, but at least we were starting to get, now the compute was kind of catching up. There were new data sets that were being released, on ImageNet was around this time. And so it was just like a really good time to dive into AI before it was kind of really big, as big as it is now. And yeah, so studied it formally, did a lot of courses in CS to develop engineering skills, but also more core concepts, understanding of probability and statistics and, linear algebra, all these things that became super relevant later. And then as kind of my degree progressed, ended up specializing even more in NLP, because I always had, so one additional maybe a bit of context is I was going to do physics and actually like a minor in kind of writing in English. And so I actually have always had a fascination with words and languages and did, studied a lot of languages in high school. So NLP felt like a really natural kind of sub field within AI to spend a lot of time on. Got involved with the NLP group there. Got really lucky to work with folks like Chris Manning and Percy Liang and Dan Drafsky in sort of a less direct capacity, but Chris Potts, who all these people who I'm sure you're very familiar with, Andrew, and really got to do a lot of cool work in NLP, language understanding, and AI broadly.
Okay, very cool. And so having gone, actually, maybe one thing you didn't mention. So I guess you started doing your early ML projects as course projects then, as compared to like, sort of side hacking projects. But I guess you were able to work on like the ML and NLP, like bigger projects as courses. Is that?
Yeah, it was a combination of both actually. So some certainly came out in the course of classes, doing the machine learning classes and doing the NLP classes. And then as I got more into it, I was kind of always on the side supplementing a lot of what I was doing with you know, Kaggle competitions, and then certainly as I got involved with research, that was totally independent of courses, right? I was just spending all my time after class doing you know, was hanging out in the NLP group, hanging out on the second floor of Gates, and you know, spending a lot of time talking to the PhD students there and working on projects. So it was a combination of coursework that maybe got me into it, and then just general interest of my own that kept me doing more stuff, right, and getting involved with more types of projects.
I see. Got it. And yeah, you mentioned sort of the timing aspect of this. So, um, I want to ask you about sort of like building bigger systems after you were at Stanford. You were at Alexa, but I think it's interesting to note that both you and I were at Stanford around the same time, and it was in this couple of years where deep learning systems were starting to perform very well on a couple of major tasks like speech
Totally.
recognition.
Yep.
Places like Google were showing that you could actually, you know, use these things in practice, and it would give you meaningful gains in performance for a bunch of key ML systems.
Yeah.
And so I think it kicked off this phase where I assume that when you went to Alexa, people were interested in doing a lot more machine learning or like more deep learning.
Yeah.
And it was kind of a bit open because we had never really, even places like Alexa had never really confronted, like, what does it mean to gather and curate massive data sets for deep learning systems? Because even speech recognizers before deep learning by comparison were
Yeah.
smaller in terms of data. So yeah, I guess maybe you can tell us what it was like in as you sort of transitioned into you know, very large organization and then building some ML projects there.
Yeah, absolutely. So yeah, I think you're absolutely right. And I did join Alexa at an interesting time because this was circa around like 2018, 2019-ish, maybe early 2019, where the Alexa product had been around, like the consumer device had been around for probably a good like 3 to 4 years at that point. So like people had Echo devices, right, in their homes and sitting on their tables and whatnot. But functionally, what these systems were able to do was very rudimentary, right? I mean, it still was maybe a Spotify, play me a song, set a reminder, put this thing on my to-do list. Like it's just really functionally very small set of things. So at this point, the kinds of problems that the organization had spent time developing and working on from a machine learning perspective and from like a language perspective were basically like ASR, right? So they had built like a reasonably good like speech recognizing systems, and so they had built, you know, they got acoustic data, they had trained systems to do that, and could do reasonably well in terms of the performance of actually understanding, at least transcribing what was being said to an Alexa system. However, the like true maybe like next generation of what they're hoping to do, and they were hoping to do with Alexa, had a lot more of a dependence on language understanding, right, and language generation. So one, how do we go from a transcribed piece of text that comes from an audio signal and then use that to understand people's intentions, what they're talking about, what they want, and then functionally from there, how can we use that to then perform some action or extract some pieces of information from like external sources, whatever those might be, and then use that to synthesize engaging, interesting, and useful responses. And so that's the generation piece of this. So all that to say that at the time that I joined, there was this, you know, a lot more of an emphasis being put on these later parts of kind of the machine learning problem, right? And it came down to more of like, how do we develop data sets to do language understanding, to do language generation? This is also around the time that systems like BERT and kind of GPT, not even GPT-3, just like, you know, GPT-1, 2, kind of the early gen systems were getting popular, right? They were just starting to pick up, and this class of transformer models were getting big. And so this also was, I think, a pivotal point in kind of the progression of NLP, where we were starting to get, you know, we're starting to be able to ask interesting questions around, you know, this new stepwise performance in kind of the models from that perspective. And so a lot of data sets were being built internally, a lot of teams were being created. Like my team was basically a new effort to be almost kind of like a Google Brain style team within Amazon Alexa, and then seeing that as like a, hey, this is where we want to put a lot of resources and time and energy and money to actually make Alexa the next, you know, bring it to the next generation and make it better than what it is.
I see. And so like a big focus on investing in like making deep learning work for some of these systems around like language understanding and language generation.
Absolutely.
So then I think oftentimes, so in our both our ML ops class and our data centric deep learning class, we focus a lot on like open source technologies and like tools that people can use to get started at smaller scale.
Mhm.
And sometimes it's sort of this feeling of like, wow, if we were at a large organization, we wouldn't have to worry about any of these things. We'd already have like a pretty good tool set and we'd be able to work at very large scale, and like all of this stuff around like building data sets and training deep learning models on them. We would just kind of spend our time on the modeling piece. So having done that at a very large, well-resourced place, what was kind of like the tools and infra situation as you were bringing up some of these things?
Yeah, it was. I wish that what you described was the state of the world, and it was just like, oh yeah, you walk inside and you just have like your perfectly provisioned clusters, and you can just hit go once you add your PyTorch or TensorFlow code, and it's all well and done. That is not the case, and certainly was not the case at Amazon at Alexa. In fact, the team that I mean, Alexa by design as an organization and Amazon by design is like a very decentralized place. So there's not like even the notion of centralized computing is something that like there was some effort to do that in the Alexa organization, where you had kind of like a centralized place, a centralized store for data, customer data, and sort of if you wanted to operate on that customer data, a set of AWS, like wrappers around AWS, basically they could use to then spin up new machines and actually run experiments using GPUs and other accelerated computing infrastructure. That being said, even in my team, I was basically the one that set up like a lot of our infrastructure. So I was the one who kind of like, every team could have their own like internal AWS account. And so I was the one that like kind of set up our internal AWS account, and then was responsible for everything from like setting up good practices around how to deal with infrastructure to actually, even establishing practices for how we were going to write our code, and low level like coding practices, because we had like our own repos, and how do you organize 20 people, 20 researchers and engineers to work on code and experiments together in a way that's productive and efficient. So it was not that simple. It wasn't just like a you walk in and that's great. That being said, that I think part of that had to do with being involved with like a new team. Like I was basically the first person under my manager, and so we really had to set everything up from scratch. Some teams that had been, kind of like the ASR team that had been around at Alexa for a longer period of time, probably had more well-defined practices in place. But I think even there, I mean, just again, one of the systems that we used, which was the only way to interface with like customer data, was effectively like a wraparound AWS. Like it all kind of eventually, you interfaced with like a different set of you interface with like different set of commands and things like that. But fundamentally, in the background, there'd be like AWS VMs and servers being spun up and GPUs. That was not the cleanest piece of infrastructure. It was really difficult to get any customer data, and maybe by design a little bit, right? That there's a lot of privacy concerns, and they wanted to make it really difficult to if there were bad players at play, which I'm not saying there were, but to be able to manipulate that data in bad ways. But in practice, as a researcher and as a scientist and engineer, it was really difficult to get into those machines, spin up those machines. There was policies where every 30 days your entire infrastructure would just get brought down, because they wanted to ensure that this wasn't gonna you didn't just persist data and one from a cost concern, but also they wanted to make sure that this wasn't just going to sit there and ultimately be compromised. So just practices like that made it actually really difficult to get some work done. And so it's not that simple. I guess it was a long-winded way of saying that even at scale, there's complexities with data and infrastructure.
And actually, so yeah, I guess I didn't realize the extent to which you were sort of on your own for bringing up some of these things. So as you were doing that, what was your team composition mostly people with like ML and sort of modeling type background, or did you bring on people who were like pure software engineering background, or maybe just like large scale computing or things like that?
Yeah, later. So at the time that I joined the company and joined the team, I was, the team grew up organically, right? So it was me and my manager at the beginning, and then as kind of the years progressed, we grew up to like 20, 25 people, and then of course more if you consider interns. That would rotating cast of interns, of course, that any big company will have. But I was probably one of the people, I mean, my background before Alexa was I had been kind of an engineer working on like large scale systems at a startup. And so I was a researcher who turned to an engineer who turned back into like kind of like a research engineer. So I probably had the most experience of anyone in terms of like architecting large scale systems and dealing with kind of research. And so in terms of my day to day, I actually like to sit in that sweet spot between, research and engineering. And I really like to span the full stack going from one end to the other. So we didn't really get like official help, where we like explicitly put out a request for engineering resources from upper level management and had them assigned to us until maybe like a year and a half into the team's existence. And at that point, a lot of my practices, for better or worse, had kind of already been inculcated into the team's way of doing things. And then when the engineers came, that we adapted things. I mean, I want to say we did like a pretty good job because we had so many researchers working on very different parts of modeling, right? There were a lot of, they were basically all researchers doing different parts of language understanding, different parts of language generation, and various other parts of the dialogue problem. And that worked, right? We were able to get a lot of work done. But it wasn't until much later that we really had like, dedicated like handful of engineers that were responsible for helping us maybe make things a little bit more robust, or helping with some of the Dockerizing of large scale systems or something like that.
I see. And so a lot of, I guess, the key sort of like ML ops design decisions and the sort of ML engineering design decisions have probably been made at that point in various ways of like,
Yeah,
how are you thinking about orchestration and how are
that's
you
right.
thinking about some data set management thing? Okay.
That's right.
Okay. So if we take something, maybe like language understanding is something that we could like abstract as like large scale supervised learning, right? I assume that for some of these, you need human annotation, you need pretty large data sets. So for a task like that, what actually mattered, or like, where did you spend the most maybe time and headaches? Because I'm guessing it was not like the transformer architecture or things like that, right?
Well, a variant of it for sure. So, again, this is around the time that certainly, I mean, from an architecture standpoint, it wasn't, people were phasing out LSTMs and GRUs and these like more old school recurrent neural network type architectures. And so transformers were the new hot thing. So everything at that point was going to be, from a language perspective, was going to be some flavor of a transformer. Like, I'm not saying that we used, directly like GPTs or BERTs necessarily, but it was like, from a monolith perspective, it was some variant of that. Now, I would say that a lot of the complexity did come up as we're scaling up, right? Amazon and Alexa had a lot of data, and we had a ton of human annotators every day, just like creating annotations. So we had, workforce in other parts of the world that would just constantly the stream of new annotations on top of data, and that was for things like transcription, things like NER. I mean, just like various types of supervised learning problems, as you're alluding to. A lot of the complexity came down to, one, dealing with data at scale, right? So dealing with like large scale systems, building large scale models around tons and tons of data, like, and I'm talking about in the order of like terabytes. And then just even understanding what we had there. I think that in the case of Alexa, discoverability was actually a big issue, because there had been at least, I mentioned that at the time that I joined, there was this like paradigm shift, or maybe like the inflection point in the company's in the organization's sort of existence, where we were starting to think more about sophisticated modeling and machine learning. But at least up to that point, that they had the good foresight to like spend some amount of time at least storing data in systems of record. So we had data that was being written to S3 buckets and kind of like external blob store. But now we, as kind of like this next generation of modelers, had to come in and say, like, what can we do with this, right? Like my team specifically, we were like, our high level charter was like, make Alexa better, make it smarter, make it like better at these kinds of things. And so we first had to like go and even understand what, when you point us to these random S3 buckets in some place in our internal infrastructure, like what do these data distributions look like? How much of this data do we have? Are these labels even any good? And a lot of these issues actually did come up, where we had, tens of thousands of data points being annotated every single day. And then we would go and actually try and build like some sort of intent classifier, or some sort of like a other type of supervised learning NLP problem. And we would just see that the distributions of like the labels was totally off. And like nobody had even like spent the time to even understand this. And so this is pretty much, useless, right? I mean, from a data perspective, I mean, not like useless, but it makes the modeling problem incredibly difficult, and you're just going to get like huge biases in the kinds of predictions that your model makes. So data distribution had to understand what was even there, and like what were the qualities and phenomena that we could even represent and were represented in our data. And then, you know, one level even past that was, is the schema even right? Like, who even developed these labels that we were using on this data that were just getting written every single day? And so we're like, hey, in NLP and language specifically, and you know, dialogue, there's nuance is important, right? Like what label is being predicted is actually like a pretty important distinction to make. And we would be in situations where this label just doesn't make sense given what we're trying to model here. Like, we need to break this out. We need to adapt the hierarchy. You know, it has to be more like hierarchical type of labeling scheme. These were all questions that we had to ask ourselves that nobody had really had the time to ask, because nobody had spent the time to investigate this data. And so that was like one set of questions. You know, and on top of that, there's also just what happens when you're dealing with trying to process terabytes of data, which is more of like kind of a compute infrastructure set of concerns.
Well, yeah. So actually, maybe one thing I want to point out, because this might not be clear for people outside of like NLP, but I think, correct me if I'm wrong, but because of the timing of this, it's important for people to understand that like systems like Alexa, prior to like 2015, 2016, certainly, they existed, and as a consumer experience, it might seem kind of the same over the years, where it's like, you know, hey Alexa, do X, right? But the way that those systems were built was fairly small scale data sets. So like your speech recognizer would be trained on like maybe a couple thousand hours of data.
Right.
You would have, I think the data Mihail's describing is, you have all this production data that you're capturing, but you're not actually using that for the most part to train your systems.
That's right.
Because the older generation of these systems, it was more like pattern matching type NLP. It was not large scale machine learning NLP.
That's right.
And so, like, I guess your team was for the first time digging into this, you know, huge amount of data. And naively, I think we always just say like, wow, we have tons of data, we'll throw it into a deep learning system, and then everything will work really well. And then it sounds like you uncovered two things that often pop up. One is like just the overall distribution of events is very skewed, right? So like your label distribution is not what you want to train a model.
That's right.
And then your annotators are not necessarily consistent enough, or your guidelines are maybe ambiguous. And so when you're training an intent classifier on a particular concept, it gets fuzzy because your training data has noise effectively. Is that?
That's absolutely right. Yeah. And I mean, I think that's really well put. And I would say that all these problems generalize to even beyond NLP, right? I mean, the distribution problem obviously can apply to like any sort of subfield of AI. And then the labeling ambiguity and kind of consistency problem, this also applies. I mean, you know, I've spoken to many folks in computer vision that struggle with the exact same things. And, you know, does this label apply to this thing? Yes and no. Maybe this label is sort of subsumed by this other label. Again, like these kinds of concerns you only start to see once you try building a model, and then you recognize that like these predictions seem off, or this doesn't accurately represent what we're actually trying to do. So yeah, all the things you described, exactly right.
Yeah, I think certainly like human annotator consistency is true no matter what the modality. Like this turns out to be a huge problem when you have like doctors like classifying medical images and stuff
That's
like
right.
that, because when you have like two experts that disagree with each other, it's like, what is the model supposed to do?
That's right.
And so, having done this at large scale, how do you think about these problems at smaller scale, right? So like if you're sort of advising a company that's bringing up, you know, NLP classifiers for different tasks,
Yeah.
are you thinking about some of these like data distribution, data quality things up front? Do you say, you know, wait until you're scaling up to deal with that? Or
Yeah. Yeah. Those concerns will always be there, and I think even at small scale, they definitely apply. One thing I've noticed though, in the case of smaller companies that I've dealt with and like consulted with and whatnot, is in the case of smaller, you know, I say smaller here, not just in terms of the size of the group, you know, even the earliness of the ML efforts in an organization, right? a lot of the concerns that they will often deal with tend to be about like resource constraints. And so that means not only like resource constraints from people perspective, so we don't have enough data scientists, data engineers to work on this. From a compute perspective, we don't have the resources to be able to do this. Like, we just can't get access to GPUs, but we're being asked to train transformers models because that's the new hot thing. How do we even do that? And then the third one is even just constraints around the data, right? So we don't have the data to do the thing that we want to do. So again, different organizations have different sort of problems. Some do already have data and they're really trying to see what they can do with it. Some don't have any data at all. And they're just coming and saying like, what is the first data set we need to build to be the first small supervised learning data set that we need to have to be able to actually do something useful. And so in a sense, the problems are a little bit different because at Alexa and at Amazon, like resource constraints were never really a problem, right? Like if we needed something, we needed to justify our case. We could get people, we could get data, we could get like compute, right? These are things that we never really had to deal with, as long as we can make like a reasonable business case for it. Of course, there's still corporate bureaucracy you have to deal with, and there's a little bit of that, but that's manageable when push comes to shove. In the case of smaller businesses and small organizations, they just they haven't gotten, in many situations, they haven't got their first like AI wins. They haven't actually gotten their first proof of concepts that machine learning even makes sense sometimes for the business problems they're trying to solve. And so for them, they need to do everything as quickly as possible to try and get to those first wins where they can make the case to like a business stakeholder or something to then say, okay, see, this is justified. Now let's go and spend more time being deliberate about data, more time getting like, scaling up the GPUs to do this. Can we get 3 data scientists instead of 1 solo data scientist off in a corner in a team of like 50 engineers that is dealing with some data set that you throw at them, right? So there's a handful of different concerns that I've seen in practice, and they tend to be more on the kind of resource constraint side, to be honest.
I see. Yeah, I think the resourcing thing, I always sort of say to people that like usually when you're working in a startup, it's nice because everything you're working on is useful, because your problem tends to be that you just don't have enough resources to like do all of the things that are important.
Right.
And then when you're in big companies, you have to be careful of the opposite thing, which is you might come across very impressively built things that are basically useless because like you have resources to build stuff, but you might not always have the priorities right on like what is the right thing to build.
That's absolutely right. That's absolutely right.
So let's see. So a bunch of what you described at Amazon is essentially what we teach in the data centric course, right? It's like thinking about managing data sets. I like that way you just described in like giving people advice. You said that there's like a separate phase, which is like data set building, right? I think that's very smart for people to think about. Of like, if we're going to start bringing up an ML system, there is a first phase, which is just like figure out the data set piece of it before you worry about the rest of your ML stack. How do you think about data centric as like a distinct set of things versus more just like good software engineering around ML, right? So like people, yes, like in myself included, I guess, are sort of starting to brand some subset of these like data set management, data quality, human in the loop annotation stuff as being like data set focused. And then the question is like, is this a useful distinction, or it can be dangerous if all you're doing is sort of saying that like good software engineering is now a separate topic, right? I want all machine learning engineering to be good software engineering. So yeah, I guess, do you think there's a useful distinction there as you like give advice to people or like think about problems for yourself?
I mean, functionally, that's actually a really interesting point. The idea that drawing this fine line in the sand is actually could be detrimental. I actually never even thought about it that way. I mean, in a sense, so much of my career has been, I've kind of spanned both ends of the spectrum, going from kind of modeling through to engineering. And so for me, I tend to maybe be a little more, I tend to be not big into like distinctions here. I like to, at the end of the day, you're just solving a problem, you know what I mean? And what tools you need to do that, in a sense, don't really quite, quote unquote, matter. insofar as like you just want to solve the problem. And so it's like, are you going to need a better model? Sure. Are you going to need more data? Sure. You should be able to do all of it, right? That maybe is not the most useful thing to the most useful representation if someone's asking like, oh, should I learn this thing? I mean, I would think about it in terms of the basic principles at play here, right? If you are trying to solve a machine learning problem, there are a few pieces you're going to have to get right. That means certainly data. That means certainly some high capacity model that's actually going to be able to learn from your data. You're going to have to do things like error analysis, like all these things. These are just like the foundational pieces of what it takes to build a fully scalable system. And then of course, like iterate on it, improve, do active learning, make sure that you're doing versioning well, and so all these things. There is a certain amount of engineering that kind of encapsulates all that. When push comes to shove, I think that you just need to understand, if you understand those fundamental principles of like what it takes to get a fully fledged system, whether you call it data-centric ML or something else, some other cool hot buzzword, doesn't really matter. I mean, unless you're trying to just like advertise yourself, which is fine, like for a job or whatever, like that's cool. If you want to, have the Coursera data-centric certification, that's fine. Like there's nothing wrong with that. But if you're just trying to take a step back and say like, what do I need to do and to learn and to be competent at to be a really successful machine learning engineer or machine learning modeler or just a machine learning practitioner, let's say, I would focus more on just like those core principles that end up applying, because the core principles are the things that persist and will persist, I believe, across the next generation of before. Like, just very simple example, recall that, like, I mean, Andrew, you're probably even you've done the days where we would like write our own gradients for doing like modeling, right? Like we actually
did PhD.
There you go. Like you were
derive your own gradients in MATLAB before PyTorch.
In MATLAB, okay, like which is crazy, right? And then we had this first generation of tools like Theano, right? If you remember Theano, like kind of, and then Keras kind of came along, and then TensorFlow. I remember when TensorFlow came out in the NLP group, like the first time, we're sitting right after the summer, a bunch of people had interned at Google, and we're sitting there going like, oh, let's try this new thing that Google had just put out. So again, and then PyTorch came out. Now there's like JAX and so all these things. So the tools and the frameworks are going to change. I believe that if you just focus on the fundamental principles, that's gonna be way more helpful. And then what you call it at the end of the day, I wouldn't spend too much time worrying about it. Just focus on the things that matter.
Yeah, I think I agree with that. Maybe so. In terms of fundamental principles, one thing that I think is useful is, so like in Mike Wu and I put together this data-centric class focused on like the things that we actually do to make deep learning systems work.
Yeah.
And most of the things that we cover in this class are not covered in like a standard graduate course on machine learning. So like if you look at basically every Stanford and other like, machine learning course, they tend to focus on the modeling side. And so I do think there's some space, like whether you call it something different or whether you just include it in your sort of machine learning coursework, of this notion of data set building and data quality as being just as important as like debugging your model in other ways.
Absolutely.
So I think, yeah, in some ways the categorization is useful for that. The other thing that, as you described this, I realize you and I probably have a similar problem in certain ways, which is if you want to get things done in machine learning, you will quickly wander away from like just the PyTorch layer of things, right? Just the modeling layer. And you create a problem for yourself, which is then people will say, well, great, now someone wants to build the platform for us. You're in charge of the platform now, right? And so in some ways, data-centric ML is like, it's using a bunch of ML ops tools, but still staking a claim that you're like doing exciting machine learning work. Because in many cases, like a lot of the data quality and data set, especially data quality and data distribution,
right,
you really impact what the model does quite a lot. So yeah, it's one way of saying like all of this data set management stuff is actually very meaningful ML work. Maybe.
Yeah. I think that's definitely a way to put it. And look, I certainly don't want to discredit the principles behind what we call data-centric ML today. Like that has been true. And I think even any machine learning practitioner will know that has always been true. The first, even years before data-centric ML became a thing, whenever something would go wrong, right, in your model, in your research, the first thing you would often be asked to do after you've like, yes, you've debugged your model and code a little bit, is you would go back and be like, okay, are these labels even right? Like, are these, are these actually consistent? Did I mislabel something? Because oftentimes, like, you mentioned your PhD in grad school, like you're maybe doing your labeling, or maybe you're using like mturk a little bit, but you're like, okay, did they label this correctly? Like, so all these principles have always been there. Now maybe what we're calling them is that's maybe like the marketing aspect a little bit that is less important to me, but yeah, the principle is absolutely like super important.
Yeah, I think it's also that just as we've gotten better at building big models, like you bump into the data set issues more because you build the model quickly, and so the impact of the data set is easier to
That's right.
observe. And
that's a good point. Yeah, that's a really good point.
So you've thought a lot about ML ops tools, like so. I think I told you this in our prep, but in our course, I say that data-centric ML and ML ops basically there's a subset of ML ops tools which are highly useful, and like data-centric ML is basically like using these things to do like higher leverage experiments, in particular things like workflow pipelines and like data quality, automated heuristics type of stuff.
Yeah.
But how do you think about the ML ops tool set, I guess, as it relates to this like data set management, data quality? I know there's other parts of ML ops, but
yeah. It's a burgeoning field. I mean, in a sense, this is still the exact tool chain to do a lot of this is still up and coming. I know that we had discussed, and you mentioned that some of your assignments involve having people use something like Label Studio, having them, work with something like Clean Lab and use that as a way of getting insights into your data quality. I think all that stuff is where there's still more to be built, but that's exactly like the right stuff. I mean, data management and kind of data quality, at the end of the day, let's say that we've like kind of some of the more like solved problems of like the MLOps landscape are things like scaling up infrastructure, maybe scaling up like an inference, making sure that you have your inference latency is solid. I mean, granted, there's still certainly work that's being done there to make that faster, containerization, orchestration of your Kubernetes clusters and Kubeflow and things like that. But let's say like maybe that is like that is like the true engineering part of the problem, like data processing at scale, modeling at scale. Like this is just like engineering in the rawest form, right? Like sometimes there's not even that much machine learning that really happens there when you're just talking about how do I scale up to make sure that utilization on VMs is like, is good, and I'm not getting like memory out of bounds, or just running out of memory on a machine. In a sense, the tooling that's getting really interesting now is all the stuff that's kind of like the messier part of machine learning. Is everything that's messy in machine learning is always the data stuff, right? And so what we're starting to really, as we spend more time deliberately as kind of a community thinking about data-centric ML and kind of the principles to do effective data management, that means building out more tooling around those early phases. But I mean, like, I would argue that data quality and data understanding should happen throughout the entire life cycle of machine learning model. But that being said, we're really getting at the point where spending time to build out that part of the tooling, that the tooling chain, is where there's a lot of companies coming out now. And that's really to deal with that fundamental messiness of everything that maybe is more kind of machine learning in nature, right? More about like data insights, data phenomena that you're trying to capture, consistency of labels, consistency of your annotators. Should all their annotations be used or not? Which subsample of this data, when you've maybe gotten some production data that's come in, which subsample should you re-annotate? I mean, all these things are more fundamental concerns that people are starting to are recognizing they need to answer, and now are starting to build tools to actually be able to answer. And so I think it's a good progression, it's a good evolution. I think there's a lot more work that needs to be done there for sure.
I see. So that focuses a lot on sort of like just understanding, and I guess maybe like visualizing and reviewing and filtering and searching of your data. That's like, I guess, both your training and evaluation data ultimately.
That's right.
Okay. Yeah, I think, what are your thoughts on, there's a couple of companies that are now, they look a little bit like ML ops tools, but their main pitch is just like their data quality services. There's like Aquarium, Clean Lab started a company. Yeah, I guess, do you think of those as like ML ops things? In some ways, I think like ML ops is running out of steam in terms of getting funding. And so now everyone's going to turn into a data quality startup, but I'm not
That's
sure.
that is that. I love that insight. We're coming back into this discussion. Another thing that's coming up again is this notion of like categorization. Like what is useful categorization versus not useful categorization. I think that I echo the sentiment. I think that ML ops got a little bit under fire from like a VC perspective in the last, let's say like 6 months to a year. And so people who have, there was this maybe 1 or 2 years ago, there was this huge influx of ML ops companies where everyone was like, oh yeah, like build tools for the ML people. That's the most useful thing to do right now. That's where there's like really there's value to be built and value to be extracted as a company. And then we had 1,000 tools that came out on the market. And now as a practitioner, I'm like, oh, which do I even want to use? They all kind of seem the same. Which was actually something useful? And as a consequence, now if you're coming in 2022 and saying like I'm building an MLOps company, you're gonna get resistance because the VC will look at you in the face and say like, well, how are you different from like any of 15 other companies? And it's hard to make a case, to be perfectly honest. So I do think there's a little bit of a rebranding going on here. Fundamentally, I think that any of these companies that are even labeling themselves as data ops companies or data quality companies or whatever they're going to end up, whatever marketing buzzword they're going to come up with so that so they distinguish themselves from every other company. I think even these players are going to end up dealing with a lot of the same, they're going to end up touching a lot of similar parts of the stack. So even when you look at something like a Clean Lab or, like an aquarium, you see this, like there's this evolution of any of these companies where even if they start with one particular niche, even if they're only tackling one specific subset of the problem, I'm only going to help you with label quality. I'm only going to help you like visualize, in clusters of your data. Inevitably, they're going to have to start encroaching on later parts of the stack. Even Aquarium is starting to do labeling. Even Aquarium will inevitably probably start doing something like modeling, just because they're, from a pure business perspective, there's not as much maybe value capture, monetizable value capture in just those like specific slivers of kind of the stack. And so I think the broad future for a lot of these companies is they're just going to try and go, they're going to go upstream and downstream depending on where they are in the stack. And that's just by necessity, to be perfectly honest. And there, it's going to be even harder to distinguish what's different, because they're all going to kind of look the same. They're all going to tend towards something like a SageMaker. You know what I mean? Like they're all just going to start looking a little bit like these end-to-end platforms where you can do everything you really need. And they want to keep you in the context of their platform.
Oh yeah. Yeah. That's unfortunate if that's kind of like the inevitable slippery slope, right? Because a lot of these things start as a Clean Lab is a very nice, specific data quality tool. I have no desire for them to manage like the rest of the process for me. I just want to use them to do that, right? But yeah, maybe that means from a business model. So do you think from a business model, people will, I guess, over time tend towards eating more?
Yeah, I mean, and I don't know how much we want to talk about this here, but a simple question is like how much, Clean Lab, I think you guys are using the open source tool, but like the moment they want to build a business around this, they need to sell some sort of an enterprise offering.
Yeah.
How much could they possibly charge you for like label quality? You know what I mean? Like ensuring that your labels are consistent. And if you're going to make like a VC backed business, you need to be able to tend toward like hundreds of millions in ARR, you know what I mean, in revenue being generated every single year. And it's hard to charge someone $100,000 if you're just making sure that, your labels are 20% cleaner. At least I believe it would be hard to charge someone that amount.
Right.
So you really need to be able to make the case for something like, the true infrastructure plays, which are like databases. Like a database is like a true infrastructure play where it's like, here's a database I'm selling you. Here's Snowflake. That's like a huge contract size that you can charge someone. So yeah, to kind of sum up that point, I think it is a slippery slope, but I think it's kind of a business necessity, to be perfectly honest. That or they'll just get acquired. I mean, I think a lot of these companies will just get subsumed by like a, Google or an Amazon or whatever, just where they're the best. If all they do is focus on data quality and they're the best tool out there for data quality, then one company that isn't have a great data quality offering will be like, okay, yeah, it makes more sense for you guys to do that here.
Yes, that is, if people are starting companies, that's a great acquisition strategy, is like, even if you don't, before you try to build out the full like must serve all these features,
Yes,
get
yes,
really good at one thing, and then
yes.
some of the big people might buy you because you're just really good at that one thing.
It's a little
Um,
risky though, right? I mean, it's like because you
yeah,
have to
it's
really
yeah.
go in on that, right? Go in that all your eggs in that one basket. But I hear you. Yeah.
Um, and so I guess on the topic of these tools, so like we have people actually on the end to end piece of that, we already have some Slack threads in our like student group, just sharing knowledge as people evaluate various labeling tools. And I think it is true that especially in the case of labeling tools, they just want to be connected to what's upstream and downstream of
Yeah.
them
Yeah.
so that you can do more interesting things like data quality feeding back into your
Yes.
annotation tool,
Yes. Yes.
or visualizing your data with the same tool you use to annotate your data, which is usually really important.
Mhm.
So yeah, I can see the sort of like stack bleed, or the the need to own more pretty clearly. Um, but so generally in ML ops, um, how do you think about people learning sort of good foundational principles
Yeah.
versus just like, here's a bunch of tools, right? Like in your blog post, you show some of these like tool diagrams, and like I don't know any of those. I mean, I know maybe 20% of like some of those pictures, but
Yeah.
yeah. So do you think people should basically like do a big survey of tools? Should they do like the ML ops? There's not great coursework yet, but it's emerging. Yeah. What do
Yeah.
you?
Yeah. I would say that definitely don't spend too much time. I definitely don't make a tool your specialization, right? I mean, that's to me, doing that is like telling a pure, backend engineer, be like, oh, you should only know Python. Like, make sure you just know Python rather than like you should learn how to code in general. You know what I mean? You should just like know what should be done to build a good piece of software. And so I think that a lot of the foundational principles that we've even been talking about are about learning learning the good practices, learning the good principles that apply and will always apply. So I would certainly never suggest that someone says, oh, build a tool in SageMaker, then build a tool in Azure, then build a tool in GCP, like, or like the Google Cloud equivalent of like all these different things, just so you can say you can do all of them. When at the end of the day, you're going to go to new jobs. Every new job is going to have a different stack, and that stack is going to be different. And if you know what's at the core of every single, what are the core principles that apply, you'll be able to adapt. And fundamentally, they're going to look very similar. So, whether or not you're using Label Studio or Label Box or something else, Aquarium versus, Scales, Scale Nucleus. I mean, these are like, I can switch out the combinations of these. I can literally spend all day going through like what would fit in and what be a good alternative. I would certainly not say spend the time to learn more than like one of them, to be perfectly honest. But what I do think is, but learn one of them, right? I mean, I think that like there is value in saying like go, when I tell people like how newcomers, how should they go into building up the skills to be like a good ML ops person, good ML engineer. I think that building an end-to-end system from data genesis, from data acquisition through to data understanding, through to like what phenomena should I try and capture and model, what labels do I need to do that, get those labels, build a model, deploy a model, run error analysis on the model based on what the based on the production data that's coming in, go back, iterate, do that full cycle. That is useful. And at the end of the day, what you choose to kind of do in doing each of those things, you'll be forcing yourself to ask the question of, okay, I want to do labeling. What labeling tool should I use? Okay, there's a few one of these. Pick one of them. Pick one of them. It's not going to make a huge difference, to be perfectly honest. Okay, now I need to do data quality. Maybe CleanLab is still one of the few good ones, and so maybe there's not as many players now, but there will be. There'll be like a handful of other CleanLab alternatives that'll come out. Pick one of them. Go with it. You know what I mean? Where should I deploy this? AWS, sure. GCP, sure. Like Azure, just pick one of them and go through that exercise fully. That going end to end is going to be a lot more useful than spending time, too much time on those blog posts where it's like X versus Y versus Z versus A versus B versus C, which is the right one. You know what I mean? Like they're gonna be fine. They're like functionally, you're not going to be hurt too much picking one or the other. Get comfortable in one and just understand what's going on under the hood enough that when you go to your new job a year from now, you'll be able to pick up the one that they're using because they chose to use AWS instead of GCP, and you learned only GCP. And that'll happen, right? That'll happen, and that happens all the time.
Yeah, I think that's a great point, and I think it's also especially given the sort of like state of the like ML ops sort of tool set. If you, I think it makes sense that like you try a project and that forces you to like confront some of these like general questions. And whatever system or tool you end up working with is probably similar enough or like has some of the same principles underneath that you can sort of map to it.
Totally.
Okay, so we're about at time. Do you have any parting advice for students that are getting into ML engineering, ML ops?
Oh boy, this is
I
the
know this is very broad.
the catch-all question.
Well, how
should I-
about, yeah, I guess you can do it on like, how about we'll do two very quick ones.
Okay.
AI in the future. Is there
Yes.
anything you want to say to us? Should we be scared? Should we be excited? Sounds like you're excited about building products with large language models.
I think we should be excited. Absolutely excited, for sure. It's a good time. It's a good time. MLOps tooling fiasco aside, I think it's a good time to be getting into this, and I expect only more good things to come out. I do really believe. I mean, clearly, I as well as you have like chosen to build our careers around this fundamental technological paradigm shift, because we've seen what it was before, and we've seen how fast we've come. In the last decade, right? I mean, just like the amount of progress in the last decade has really been stunning. And in the last 6 months has been stunning. And just expecting that, there's a little bit of an optimism, like a technological optimism that like, yes, extrapolate out to infinity. And like, there's only more amazing things that are going to happen. So bullish 100%.
And then how about, so for people working in the space, sounds like working on end-to-end projects is top advice. Any other big advice for people getting into the space?
Yeah, end-to-end project, build something from scratch, really go through that exercise. And this I think is good, having courses like this. Advice that I think still does apply sometimes when I have people that are like, oh, should I do data science or should I do ML engineering? I have a bias towards spending a lot of time on engineering skills because I was an engineer in a past life, and I almost deliberately I went from being like a pure researcher, in kind of at Stanford, where all I did was write really bad Python code, to saying like, hey, I need to get better at this. Like, I feel like I need to build out I need to learn the tools of my trade, spend more time actually learning good engineering practice, and then came back. And let me tell you, when I came back from like a more pure software engineering job into being like kind of a research engineer sort of hybrid, my own research productivity went up by like 10x because I was just like so much faster at like architecting systems, at thinking about clean abstractions, at debugging things. Like any problem that I faced ever, even when it came down to research, I just like was not fazed by it because I'm like, I feel like I'll solve this eventually, right? And I have the tool set to know how to do this. So the other thing I would say is engineering will always be useful, and here engineering applies to things like of course data construction, data analysis, and doing that in a robust and scalable way. Do spend the time to learn those skills. They will absolutely be useful.
Awesome. Yeah, I definitely agree. Like it's always, you should not let sort of and software engineering slow down your ability to like express your data science ideas.
Exactly.
Right.
Exactly right. Yeah.
Okay, Mihail, thank you so much. This was very fun.
Andrew,
On behalf of all of our students. And yeah, students, if you haven't already checked out, Mihail has some blogs, mostly on LinkedIn you post, or Medium and LinkedIn.
All over.
And Twitter, right? So yeah, you should check out his stuff. Definitely at least the ML Ops blog post. I put it in our Slack as well. Okay, thank you again, Mihail. Thank you everyone for coming. And we'll see you later.
Absolutely. Thank you, Andrew. Thanks, everyone.
Thanks, everyone.